take this as the exercise for, the first part of plane mensuration. Take this as your class exercise, at least for the first two videos. So here, the question says, using the diagram in question 2, that means using this diagram here. Using the diagram in question 2, find the area of each of the following: triangle ADK, triangle ADG, JEF, and so on. So you trace it. You trace each shape on the, on the diagram, and you find its dimension. Use its dimension to calculate its area. Here, for example, in triangle ADK in question 1A, it says, question 1A says find triangle ADK. So let me show you here. This is triangle ADK. This is triangle ADK. So if you want the area of this triangle, your base is 6 plus 6. This is, all of this is 16. 4 plus 5 plus 7, that's 16. So that means this length should also be what? 16. And 6 and 4 are written. So 6 plus 4, 10. Subtract 10 from 16, you get 6 for this place. So that tells you that the base is what? 16. The base is 16 and the height is 4. So half base times height will give you the area. That's the answer to question A. So let me go on and maybe give you a hint in each one or some, at least. Question B says find the area of triangle ADG. If you want the area of triangle ADG, so first thing, you trace out the triangle itself. What's the area of triangle ADG? That's the area of this triangle, ADG. Let me try and make that neat. This is the area, this is the triangle ADG. I've traced triangle ADG now. The base of the triangle is this length, which is what? 16. This whole length here, which is 16. That's the base of the triangle. Then what's the height? The vertical height is here, which is 13, same as this side. So half base times height, half times 16 times 13 will give you the area of the triangle. You do it yourself. C says find the area of triangle JEF. So let's trace JEF from our diagram. Where is J? This is J. Where is E? This is E. Where is F? So this is triangle JEF. Excuse me. That's not straight. That was not straight. So this is triangle JEF. So your base is what? 16. And your height is, I think we found this many times, 6. So the area of triangle JEF will be half base times height. This base and height are perpendicular. The base is 16, the height is 6. So half times base times height. You write your formula first, then you write half times 16 times 6. Triangle EFG is the next question in D. Triangle EFG. This is triangle EFG. So the base is 7, the height is 6. Half base times height will give you your area. Triangle DGF. Question E is triangle DGF. This is D, this is G, this is F. So I'm looking for the area of this triangle DGF. Of course, I know 4 plus 9, my height is 13. This whole place is what? 13. So this is 13, my base is 7. Half area is half base times height, and that's half times 7 times 13. This is the perpendicular base, 7. This is the perpendicular height. So half base times height, that's half times 7 times 13. We're giving the answer to question E, which is the area of triangle, DGF. Let's go ahead to question F. In question F, we have to find the area of triangle BGC. Find the area of triangle what? BGC. Let me mark BGC out. This is triangle BGC. So my base is 6. I've shown you that many times. And my height, my perpendicular height is the same as this side, 13. So half base times height. First you write area is half base times height. First of all, write the formula. Area is half base times height. Then substitute values into your formula. Area will be what? Half times 6 times 13. So take note of that. H is triangle KEJ. Triangle KEJ. Let me mark that. Triangle KEJ. So my base is 9. This is my base 9. My vertical height is the same as this side, which is 16. So half base times height, we give you the area of the triangle. You write the formula out first. Area is half base times height. You substitute. Area is half times 9 centimeters times 16 centimeters. That will give you the area of question F for triangle KEJ. So hold on, let me clean everything so it will not mix with the next one. Next question is G, triangle BJD. We have to find the area of triangle BJD. Let me trace that for you too. BJD is, I can trace BDJ also. BJD. So this is the area of BJD. This is J. So all I need is the base, and I have it. The base is 10 here. 6 plus 4, 10. So you have the base. The vertical height is the same as this length. This is the vertical height. So half base times height will give you half times 6 times 13. The vertical height is 13 centimeters. So that means the area of triangle BJD or BDJ is half times 10. Half times 10 times 13. The base is 10, not 6. 6 plus 4 will give me 10. Question H. I need the area of triangle KEJ. Let's go ahead and trace KEJ. Area of triangle KEJ. This is KEJ. So that's what? Half times 9 times 13. I think that's the same as one of the questions I read before. Anyway, question I says I should find the area of triangle BHE. How do I get the area of triangle BHE? First, let me trace triangle BHE. This is BHE. This is triangle BHE. So all I need to do, this is a simple question. BHE is a part of this trapezium BDHE. So I'll find the area of this trapezium. The two parallel sides are 12, 5 plus 7. 12 and what? 10. Those are the two parallel sides. And my vertical height is what? My vertical height is here, 13. So half into bracket A plus B. Half into bracket 10 plus 12 times H, which is 13, will give me the area of the trapezium. After getting the area of the trapezium, I will now find the area of triangle A. This side is 6. The area of triangle A, this triangle, the area of triangle A will be what? Half base times height. Let me change my ink to purple. The base is 10, the height is 7. Half base times height will give me the area of triangle A. I'll find that. Then find the area of triangle B also. In triangle B, my base is 12 and my height is 6. So I'll add the area of triangle A to B, subtract it from the area of the whole trapezium BDHF, and get the area of the triangle BH. That's a very simple question too. I gave examples like it. Next is the area of triangle DKC. Let me mark that out. Area of triangle what? DKC. This is D. This is D. K. This is triangle DKC. Okay, that's pretty funny. My base is 4. My vertical height is also 4. So half times base times height, half times 4 times 4 will give me the area of triangle DKC. Never mind how it looks. The vertical height is 4, and the base is what? Also 4 here. So the area of triangle DKC will be half times 4 times 4. Area of trapezium BCJF. Let me quickly hint you on that too. Area of trapezium BCJF. BCJF is here. JF. So this is 6. I've shown you that many times. This whole length is what? 16. So my two parallel sides are 6 and 16. Then the vertical height of the trapezium is here, 13. So half open bracket 6 plus 13 bracket closed times, half open bracket 6 plus 16, A plus B, bracket closed times 13, which is the vertical height. Will give you the area of the trapezium. You write your formula first. In every question you are answering, write your formula first. Area of trapezium is half open bracket A plus B times H. There will be mark for this before you start substituting. Please take note of that. Very, very important. Let's go to the next question I gave. Area of quadrilateral CK. Area of quadrilateral CKHE. What's the area of quadrilateral CKHE? Here, where is CKHE? Let me mark CKHE. This is CKHE. This is quadrilateral CKHE. So this one is a very simple question too. All I need is to find the area of the, of the O shape, which is the area of the full rectangle. You understand? And subtract the area of these triangles from it. This one, A, B, C, D. That will give me the area of quadrilateral CKHE. For each of those triangles, I know what my base and height should be. So you figure that out yourself and subtract. Number 2 is very simple, just like our previous example. Now, let's continue with the exercise from question 3. Let's continue with the exercise from question 3. Now, question 3 says, a rectangle 9 centimeters long. This rectangle is 9 centimeters long. Is equal in area. The area of the rectangle is equal to the area of a square, which has a perimeter of 24 centimeters. Now, if the area of the square is, if the perimeter of the square is 24 centimeters, what will be the length of the square? Perimeter of a square is length plus length plus length plus length. You understand what I'm saying here? L plus L plus L plus L. So if you add all 4 lengths, which is 4L, you will get 24. That's what the perimeter being 24 means. So 4L is 24, 4L is 24, L is what? 6 centimeters. That means the length of this square is 6, 6, 6, 6. You understand? The question now says the area of the rectangle is equal to the area of the square. What do we do? Area of rectangle is length times breadth, or length times width. Area of a square is L squared. So that means L times W is what? 6 squared. And the length of the rectangle is given as 9. So 9 times W is 36. That gives me what? The width of the rectangle as 4 centimeters. So take note of that. That was a simple question. Question 4 says, find the length of the side of a square that is equal in area to a rectangle measuring 45 centimeters by 5 centimeters. So here, the area of the square is equal to the area of the rectangle. And the rectangle measures 45 by 5. So the area of the rectangle is length times breadth, which is 45 times what? 5. 45 times 5 will give you 225. The area of a square is length times length. So that means length times length, L squared, is 225. L will be square root of 225. The length of the square is 15 centimeters. Let's go to question 5. Question 5 says, what is the area of the shape in figure 12.4? What's the area of the shape in figure 12.4? This is not a regular shape. So we cannot call it a square, we can't call it a rectangle, we can't call it a triangle. It's a, it's a combination of either 2 or more rectangles or 2 or more squares, or rectangles and squares. So let's break them into different parts. So if we break it here, I'm going to change this to yellow. If we break it here and here, I have this side as side A. this side as side B, and this side as side C. Let me now find the dimensions of each. Side A, we have length 8 centimeters and what? Breadth 2 centimeters. It's been shown here that the breadth is 2. So this side 2 will be 2. So that means A is a rectangle of dimensions 8 by 2. Now go to B. In B, this is given as 9 centimeters. This 9 centimeters is the length of the whole side here. 9 centimeters. But we are told this is 2. If you take 2 from 9, you will get 7 here. So that means the breadth of B is what? 7 here. I've written it in this corner. And it's what? Sorry, that means the length of B is 7 and its breadth is what? 3. So if this place is 3, this place is also 3. So B is 7 by 3. B is a 7 by 3 rectangle. Go to C. C is a 7 by 2 rectangle. So we find the area of each, length times breadth, since they are all rectangles. That will give me 8 times 2 plus what? 7 times 3 for B plus what? 7 times 2 for C. So that gives me the area of my shape. I'll just add up all my answers. That's question 5. Now go to question 6. Question 6 is straightforward, simple. It's a small semicircle cut out of a big semicircle. This small semicircle is cut out from a big semicircle. So all we need to do is find the area of the big semicircle, find the area of the small semicircle, and subtract that of the small one from that of the big one. Very simple. So the shaded area will be area of big semicircle minus area of small semicircle. Fine, sir. Okay, am I concerned? So that's what? Half pi r squared minus half pi r squared. That gives you what? How do we get big R? I think that would be a question here. How do we get big R? This place marked 6. If you cut it into 2, there will be 3 on each part or on each half. Now, this place is the center of the figure. Add 3 to 8. Add 3 to 8. If you add 3 to 8, you will get 11 for the big radius. So this big radius is what? 11 centimeters. You understand? And that's the radius of the big semicircle. If you also look at this small semicircle, the radius of the small semicircle starts from this center to this end, and that will be what? That will be 3 centimeters. So I have my big R as what? 11 centimeters, and I have my small r as 3 centimeters. So half pi r squared minus half pi r squared, because the area of a semicircle is the area of a circle divided by 2. So half pi r squared, pi r squared over 2 is the same thing as half pi r squared. So that means the area of the big semicircle is half pi r squared. The area of the small one is half pi small r squared. So I can factorize half pi. I'll get r squared minus r squared. After subtracting, that's 11 squared minus 3 squared. After subtracting, I can also use difference of 2 squares like this and simplify. I'll get my answer as 176 centimeters squared. That's the answer to question 6. Let's go to question 7. The shaded portion in question, the shaded portion in question 7 is what is left when a small circle is cut out of a big circle. So that means the area of the shaded portion is the area of the big circle minus the area of the small circle. So in this case, we are given small r as what? We are given small r. We are told that big R is 3 times small r. We are told that, the big radius is 3 times the small radius. So area of big circle, pi r squared, minus area of small circle, pi small r squared, is pi, anywhere we have r, we just put 3r. that's what, let me try and show you here. Pi, instead of writing r squared, I'm just going to write 3r squared, then minus pi r squared. Is that clear? Now, for this 3r squared, you will notice that 3 will be squared. That gives me 3 times 3, 9. R will also be squared. That gives me r squared. So that's how I got pi 9r squared. That's how I got pi 9r squared minus pi r squared. You understand? So that gives me pi, this will give me pi 9r squared. This gives me pi r squared. You understand? Pi 9r squared minus pi r squared. So if I take out the pi, I have pi 9r squared minus 1r squared. Although I may not write the 1, but it is there. So 9r squared minus 1r squared will give me 8r squared. So that means the area of my shape is pi times 8r squared, or 8 pi r squared. The area of my shaded portion is what? 8 pi r squared. Take note of that. Subtraction of areas. Now, let's go to question 8. In question 8, it says the parallel sides of a trapezium are 11 centimeters and 13 centimeters. Check this out here. 11 centimeters and 13 centimeters. You put 11 on the shorter one and 13 on the longer one. The question says, if the area of the trapezium is 84 centimeters squared, calculate the perpendicular distance between the two parallel sides. Put the perpendicular distance here, h. The area of a trapezium is half open bracket a plus b times h. So that's half times 11 plus 13 times h. That will give me half times 24 times h. 12h is 84. H is 84 over 12, 7 centimeters. In question 9, it says a triangle is equal in area. A triangle is equal in area to a rectangle, which measures 10 centimeters by 9 centimeters. So for the rectangle, length is 10 centimeters, breadth is 9 centimeters. If their areas are equal and the base of the triangle is 12 centimeters, we are required to find the height of the triangle. So very simple. Area of triangle is equal to area of rectangle. That means length times breadth is equal to what? Half base times height. This for the rectangle and this for the what? Triangle. So 10 times 9 is equal to half times 12 times h. 90 will be 6h. H is 90 over 6 to get 15 centimeters. In question 10, it says a bicycle wheel has a diameter of 63 centimeters. Calculate how many times the wheel turns round in traveling 19.8 kilometers using the value 20 over 7 for pi. 1 over 7 is in this corner, which is the same thing as 22 over 7 for pi. So it's a simple question. All we have to do is say distance traveled. Say distance traveled is equal to the circumference of the bicycle wheel times number of revolutions. Let's say the circumference of the bicycle wheel is, 20 meters. That means if it turns once, it has covered the distance of 20 meters. If it turns twice, it has covered the distance of 20 times 2, 40 meters. So on and on like that. Distance traveled is equal to the circumference times number of times it turns, or number of revolutions. So 19.8 kilometers is 2 pi r for circumference times n. So 2 pi r times n is 19.8. In this question, you need to keep your units equivalent. So I'll do n is 19.8 over 2 pi r. But I have to be careful. 19.8 is in kilometers and my radius is 63 centimeters. So I need to make some adjustments to make sure my units are both either in kilometer, or centimeter. So it will be better to change 19.8 to centimeters. 19.8 kilometer to meter, you multiply by 1000. That changes your distance to meters. Then that distance in meters multiplied by 100, we change it to what? Centimeters. So my answer is all of this divided by 2 times what? Divided by, 7 here 1, 7 here 9. divided by 2 divided by 22 divided by 9. So that gives me 5,000. That means the wheel turns 5,000 times to cover a distance of 19.8 kilometers. Take note of that question, very important. In this question, we are told that in triangle PQR, QT and PM are altitudes. So what that means is simple, that 7 times QT is an area. Do you understand? Here, 7. This length, 7. 7 times what? Times height QT. 7 times height QT will give me the area of the triangle. That will serve as base times perpendicular height. Also, in the same vein, also QM times PM. I said QM. Also, QR times PM will also give me the area of the triangle in the same vein. That's base times height, half base times height. You understand? So half times 7 times QT will give me my area. And half times what? QR times PM will also give me my area. Both of them stand for half base times perpendicular height. So that's what I've written here, as you can see. Check very well. So half we divide half. You have QR times PM is equal to PR times QT. You understand? That gives 8 times PM is 7 times 4. And PM will be, 7 times 4 over 8. That's 3.5. So let's go to question 12. Question 12 is similar to question 11. Question 12 is similar to question 11. The diagram is not drawn for us. We have to draw it ourselves. So ABC is a triangle, and what? It says BM and CN are altitudes. So BM and CN are altitudes. This is an altitude, and what? This is also an altitude. That means a vertical height of the triangle. So 3.5, the base, times what? CN, the vertical height. You understand? Half times base, 3.5 times CN, the vertical height, will give me the area. Also, half times 3.2, which is AC, times BM, which is a vertical height perpendicular to AC, will also give me the area. So if I equate the two, half base times height, you understand? Half base times height, that's half times AC times BM. You understand? I'll get my area. If I also equate, if I also do half times what? Half times AB times CN, I also get my area. So that tells me that half times, 3.5 times CN is equal to 3.36, which is the area. Then I can do division to get my CN as 1.92 centimeters. That's question 12. Let's go to question 13. In question 13, we are told that, in question 13, we are told that ABCD is a parallelogram, and AM and AN are what? AM and AN are perpendiculars from A to BC, and what? And from what? And from A to CD. If AB is 6.3, you can see in the diagram, if AB is 6.3 and AD is 4.9 and AN, if AB is 6.3, AD is 4.9 and AN is equal to 4.2, calculate the area of the parallelogram and hence find AM. This is a simple question. Area of a parallelogram is base times perpendicular height. I have a base here, which is what? 6 point what? I have a base here which is 6.3, and it is perpendicular to this vertical height, 4.2. So I can just use that to get my area of the parallelogram. 6.3 times 4.2 will give me the area of the parallelogram. Area of a parallelogram is base times perpendicular height. So that gives me the area of my parallelogram. Now, take note. The question also says I should find what? Says I should find AM. So I will now go back and say AM is the same thing as what? Excuse me. This is somehow misbehaving. Let me see if it will have sense here. Okay. All right. So base times perpendicular height here. I need to find AM. Also, this base BC times perpendicular height AM will also give me the area of the trapezium. You understand? And BC is 4.9. Since AD and BC are opposite sides, and opposite sides of a parallelogram are equal and parallel. So if AD is 4.9, BC is also what? 4.9. BC is also 4.9. So 4.9 times AM will give me the same answer I get here. So I can now use that to get my answer. My area was, 26.46 from here. 26.46 is my answer here. So I will go ahead and do 4.9 times AM is equal to 26.46 area of the parallelogram. So AM is 26.46 divided by 4.9 to get my answer. What you just need to know here is that you have two expressions that can give you your answer for the area. You understand? BC times AM, base times perpendicular height. You also have this to get the area. AB times what? AN, also base times perpendicular height. You equate the two. This will give you the area. Then in the second row, or in the second, equation, you use your area to find AM. Question 15 now. Question 15 says the area of what? Of a square is R centimeters. Write down an expression for half its perimeter in terms of R. The area of a square is R centimeter. Okay, that was question 14. That's question 14, not 15. The area of a square is R centimeters. Write down an expression for half of its perimeter in terms of R. Very simple question. Area of a square is what? L squared. So that means L squared is R, since the area is R centimeter squared. So the length of the square will be square root of R. That's what? Root R centimeters. Keep that. Now, perimeter is 4 times length. For a square, perimeter of a square is 4 times length. So that means the perimeter is what? 4 times R. 4 times root R centimeters. So half of the perimeter, for which we are to write an expression, will be 4 root R all over 2. 2 we divide 4, you get 2 root R for half the perimeter of the square. Now, let's go to question 15. Question 15 says, the length of a rectangle is 3 times its width. If the perimeter is 72, calculate the width of the rectangle. This is pretty simple. Take note that the perimeter of a rectangle is what? The perimeter of a rectangle is 2 open bracket length plus breadth. So that means 72 is 2 open bracket 3W. Since the length is 3 times the width, we write W for the width and we write 3W for the length. So 2 times 3W plus W will give me what? 72. As in, perimeter is 2 times length plus what? Breadth. So length plus breadth here, 3W plus 1W gives me 4W. So 2 times 4W is what? 72. 8W is 72. And W is 72 over 8. So that means the width of the rectangle is 8 centimeters. That's the width of the rectangle. So that means its length will be 3 times width, 27 centimeters. Is that clear? Please take note of that. I hope you are getting this. Very easy. It's a very simple topic in maths. Plane mensuration is very, very easy. 16 says the area of a trapezium is 14.7 centimeters squared. If the parallel sides are 5.3 and 3.1, find the perpendicular distance between them. This was similar to a question we answered. Area is 14.7. Opposite sides are A and B. Half open bracket, A plus B is area. So equate your expression here to what? 14.7. And 3.1 plus 5.3 will give you 8.4. Half of 8.4 is 4.2. 4.2h is 14.7. So what do you do? Okay, I don't need to do this. I just need to put the answer together. 14.7 is 4.2h. H is 14.7 over 4.2, which will give you your answer in centimeters. Is that clear? Take note of that, please. Number 17. Number 17 says, PQRS is a parallelogram. So if this place is 6, what it means is that if this place is 6, this part will also be what? 6. The questioner says, if this is 90 degrees, if this is 90 degrees, it says that what is the area of the parallelogram? Okay, if this part is 90 degrees, if this part is 90 degrees, all we need to do is, find this place. All we need to do is find, for the parallelogram, we need the base times the perpendicular height. We need the base, which is 6. We need the area of this parallelogram. Area of a parallelogram is base times perpendicular height, and we need this perpendicular height. You understand? We need this perpendicular height, h. Now, that perpendicular height is the same thing as this side. So, if this side is 6 and this side is what? 10. In this right angle triangle, this is what? A right angle triangle. So we can use this to get h by saying h squared plus 6 squared is equal to 10 squared. That will give us what? That will give us HP, which is our h, as what? 8 centimeters. So we now get the area of the parallelogram. Base times perpendicular height will be 6 times 8 centimeters, which gives 48 centimeters squared. That was a very easy question. Question 18. In question 18, it says calculate the area of each of the shapes in the diagrams below. All dimensions are in centimeters. That's a very simple question. The area of a triangle, when you know 2 sides and the included angle, is simple. Area of the triangle will be half times the 2 sides times the sine of the angle between them. So the area of my triangle is half AB sine what? Theta. Half AB sine theta. That will give me half times 10 times 4 times sine 50. So you take note as I'm showing you. Then we are also to find the area of this triangle. This one too will be half times the area of the second triangle in 18B will be half times 6 times 6 times sine 38. That's very easy there. So take note of that. Question 19. In question 19, okay, there are more questions in 18. For C, the area of the trapezium, the area of the parallelogram in C will be AB sine theta. Area of a parallelogram is the product of the 2 adjacent sides times the sine of the angle between them. So area of this parallelogram is going to be 5 times 8 times sine 63. But take note, you must write this formula down first. So area is AB sine theta. You now substitute 8 times 5 times sine 63 to get your answer. So the second one is the same way. If this is 124, this angle too will be 124. So if this angle is 124, this one too is 124. So that means between 4 and 2.5, you have 124. You can now do 2.5 times 4 times sine 124 to get your answer. Question 19. Question 19 is equally easy. Calculate the area of PQRS. So this is a trapezium, but we don't have the vertical height of the trapezium. The question says PQR is 30 degrees, that this angle is 30 degrees. So we can use our trig ratio to say sine 30 is what? Opposite. The H is the opposite. Sine 30 is opposite here over hypotenuse here, since this is a right angle triangle. So maybe I should take it out. Right angle triangle, 30 opposite hypotenuse. So sine 30 is what? H over 12. If sine 30 is H over 12, that means what? H will be what? 12 sine 30. Sine 30 is H over 12. So if you cross multiply, 1 times H will give you H. H is equal to 12 sine 30, which is 6 centimeters. So after getting your vertical height at 6 centimeters, you have everything you need to find the area of the trapezium. So this is the vertical height here now. This is my vertical height here now. So I can now do half AB. This is my A, 8 centimeters. This is my B, 16 centimeters. So you can now do half open bracket A plus B times H. 8 plus 16 times what? 6 to get your, area of the trapezium. So question 20 says the area of a parallelogram. Question 20 says the area of a parallelogram ABCD is 43 centimeters squared. AB is what? 7 centimeters. BC is 9 centimeters. And ABC is what? Less than 90 degrees. So I've drawn this to show that it is acute and less than 90 degrees. The question says calculate ABC. Calculate angle ABC to the nearest degree. This is a simple question. Just write the formula down, that the area of the parallelogram is AB sine theta. So your A is 7, your B is 9. Sine theta is equal to what? 43 centimeters squared. So what do you get? You will get 63. Sine theta is 43, is equal to 43. Then, sine theta will be 43 over 63. Then find arc sine theta to get your answer. So your answer will be here in degrees. So use your arc sine table to do that. There will be an exercise for, these remaining examples I've just explained in the next video, inshallah.